The difference of two squares identity says that for all real numbers x and y, x squared minus y squared equals x plus y times x minus y. Now this expression is an identity, it's not an equation. An identity means that the left-hand side is always equal to the right-hand side, regardless of which values of x and y you choose. The difference between an identity and an equation is that an equation is only true for some values of x and y. For an identity, the left-hand side is always equal to the right-hand side. We can check this identity for specific values of x and y. So if we take x equals 3, y equals 2, then x squared minus y squared is 3 squared minus 2 squared, which is 9 minus 4, which is 5. And x plus y times x minus y is 3 plus 2 times 3 minus 2, which is 5 times 1, which is 5. So both sides are the same. If we take x equals 8, y equals 10, then x squared minus y squared is 8 squared minus 10 squared, which is 64 minus 100, which is minus 36. X plus y times x minus y is 8 plus 10 times 8 minus 10, which is 18 times minus 2, which is minus 36. So both sides are the same. Because the difference of two squares expression is an identity, not an equation, we sometimes write an extra line under the equals sign, like this, to show that that is the case. This is the first algebraic proof of the difference of two squares identity. We rewrite the right-hand side in the same form as the left-hand side. We do this by expanding x plus y times x minus y. So we have x times x is x squared, x times minus y is minus xy, y times x is plus yx, y times minus y is minus y squared. We can rewrite that as x squared minus xy plus xy minus y squared, because we can interchange the order of multiplication. Then we can cancel the two terms in the middle to give us x squared plus 0 minus y squared. And we can rewrite that as x squared minus y squared. So the right-hand side can be rewritten in the form of the left-hand side. This is the second algebraic proof of the difference of two squares identity. We show that the right-hand side can be rewritten in the same form as the left-hand side. We have x squared minus y squared, which equals x squared plus 0 minus y squared, which equals x squared plus xy minus xy minus y squared. We now factorize the first two terms and the last two terms to get x into x plus y and minus y into x plus y. And we have common factors x plus y, which we factorize out to give us x plus y into x minus y. So the right-hand side has been rewritten in the form of the left-hand side. This is a geometric proof of the difference of two squares identity. X squared represents the area of a square of side x, like this. Y squared represents the area of a square of side y, like this. So x squared minus y squared represents the difference of those two areas, as in this shape, where we have removed a square of area y squared from a larger square of area x squared. If we examine the shape on the left, we see that this side has length x minus y, and this side has length x minus y. So this distance is also x minus y. Now we can rearrange the areas in the shape on the left into the shape on the right. So if we take this rectangle and place it here, we have turned the shape on the left into the shape on the right, and they must have the same areas. Now we can see that the long side of the rectangle on the right has length x plus y, and the short side has length x minus y. Now, the area of the shape on the left is x squared minus y squared, and the area of the shape on the right is x plus y times x minus y by multiplying the lengths of the sides together, and those two areas must be the same, so we can say that x squared minus y squared equals x plus y times x minus y.